Did you know that the oxygen you breathe, the iron in your blood, and the carbon in your body all came from a star that exploded? Stars are not only responsible for creating all of the light and heat that we enjoy here on Earth, but they're also responsible for making all of the matter that we're made of. But this wasn't an easy task. It took billions of years and many failed attempts before our solar system was finally able to produce the perfect mix of elements needed for life. It all started with the Big Bang. In the first few minutes after the universe formed, it was extremely hot and dense. There were no stars or galaxies yet, only fundamental particles like protons, neutrons, and electrons. As the universe expanded and cooled, these particles began to combine to form the first atoms, mostly hydrogen and helium. But that left scientists with a problem. The periodic table of elements lists all of the different chemical elements, but the vast majority of them don't exist naturally. They have to be created in the labs by nuclear reactions. And since the early universe was so hot, there wasn't enough time for these heavier elements to form. So how did we get all the elements that aren't hydrogen or helium? Well, it turns out that we have stars to thank for that. Over the next few billion years, gravity caused the hydrogen and helium gas to collapse into the first stars. These stars would burn brightly for millions of years, converting hydrogen to helium through nuclear fusion. This fusion is what powered the first stars and gave off the light and heat necessary for life to eventually evolve here on Earth. However, stars didn't just make helium. During their lifetimes, they were constantly bombarding space with cosmic rays. These are high-energy particles moving at near light speed. When these cosmic rays hit other objects in space, they could cause nuclear reactions that produced heavier elements like carbon, oxygen, and nitrogen. For example, when a cosmic ray proton hits a nitrogen atom, it can knock off one of its neutrons and transform it into a carbon atom. Scientists think that many of the elements up to iron were produced in this way during the early years of the universe. But where do the even heavier elements come from? Well, that's where massive stars come in. As a massive star ages, it fuses lighter elements together to make heavier ones. They start off their lives burning hydrogen into helium. But eventually, they run out of hydrogen and start fusing helium into heavier elements like carbon and oxygen. And then they keep going. They fuse those elements into even heavier ones like neon, magnesium, and silicon, until they reach iron. At this point, the star has fused almost all of the matter inside of it into iron. It's at the end of its life and it's about to explode. When a star explodes, it doesn't just blast apart. It goes out in a blaze of glory. A massive star's explosion is called a supernova. During a supernova, the iron core of the star collapses in on itself, causing a massive release of energy. This energy blast is so powerful that it blows the star's outer layers out into space. This material includes elements that the star had fused during its lifetime. When these elements are blown out into space, they become available for other stars and planets to form from. This process is called stellar nucleosynthesis. It's how stars use nuclear fusion and explosions to create new elements. So where do we fit into all of this? Well, scientists think that many of the elements that are essential for life, like carbon, oxygen, and iron, were spread throughout our solar system by exploding stars. These elements are called alpha elements because they have a balanced ratio of protons and neutrons. If you look at the periodic table, you'll see that they're located in the middle of the chart. Now, this isn't just a coincidence. It turns out that elements with a balanced ratio of protons and neutrons are more stable and therefore more likely to occur in nature. That's why so many of them are found in our bodies and in the Earth. Take iron, for example. It's essential for life because it's a key component of hemoglobin. Hemoglobin is the protein in red blood cells that carries oxygen throughout the body. Without iron, we wouldn't be able to transport oxygen to our organs and muscles, which would quickly kill us. But iron is also toxic in large amounts. Too much iron in the body can damage cells and organs and lead to a condition called hemochromatosis. People with this condition have too much iron in their bodies, and they can develop symptoms like fatigue, joint pain, and organ damage. That's why it's important to have just the right amount of iron in our bodies. Too much, not too little, and that's where our solar system comes in. The reason that we have the perfect amount of iron in our solar system is because it was produced by exploding stars. Stars are like cosmic chemists. They take lighter elements and fuse them together to create heavier ones. When a star runs out of fuel, it explodes and spreads these elements throughout space. Our solar system formed from a cloud of gas and dust that was enriched with these alpha elements. And we just happen to be in a solar system that has the perfect amount of each one. But why do we need just the right amount of each element? Well, that's because each element has a unique role to play in the formation of planets and life. Take carbon, for example. It's essential for life because it's the backbone of all organic molecules. That's why we call it the element of life. Carbon can form 4 bonds with other atoms, which allows it to form long chains and complex structures. This makes it ideal for building the molecules that make up living things like proteins, carbohydrates, and lipids. But carbon is also unique in that it can form both single and double bonds with other atoms. This gives it a lot of versatility in terms of the types of molecules it can form. For example, carbon can form methane, which is a simple molecule made up of 1 carbon atom and 4 hydrogen atoms. Or can form diamond, which is a complex molecule made up of multiple carbon atoms bonded together in a tetrahedral structure. This versatility is what makes carbon so useful for building the molecules that make up living things. But carbon isn't the only element that's important for life. Oxygen is also essential for life as we know it. That's because most of the water on Earth is made up of oxygen and hydrogen. Water is a polar molecule, meaning that it has a positive and negative end. This makes it a great solvent, which means that it can dissolve a wide variety of substances. This is important because many of the molecules that are involved in chemical reactions are dissolved in water. Water also has a high heat capacity, which means that it can absorb a lot of heat without changing temperature. This is important for maintaining the temperature of Earth's surface within a range that is suitable for life. And finally, water has a high surface tension, which means that it can form droplets. This is important for processes like capillary action, which is how water moves through plants. But while oxygen is essential for life, too much of it can be dangerous. That's because oxygen is highly reactive. It can easily combine with other atoms to form molecules like ozone, which can damage cells and DNA. That's why it's important for the amount of oxygen in the atmosphere to be just right. And then there's iron. We already talked about how important iron is for transporting oxygen in the blood, but it also plays an important role in photosynthesis. Photosynthesis is the process by which plants and other organisms convert light energy into chemical energy. Iron is an important component of chlorophyll, which is the molecule that captures light energy in plants. But having just the right amount of these elements isn't enough. They also have to be in the right place. If they're too far away from Earth, they won't reach our planet. Or if they're too close, they could be dangerous. For example, if there were too much iron in our solar system, it could damage our cells and organs. That's why it's important for the amount of each element to be just right. For example, our solar system is in the habitable zone of the Milky Way. The habitable zone is the region around a star where conditions are just right for liquid water to exist on the surface of a planet. If our solar system were closer to the center of the galaxy, there would be too much dust and gas, which would make it difficult for our solar system to form. If it were farther away from the center of the galaxy, there would be too much space junk, which would make it dangerous for Earth to orbit the Sun. You might be wondering how we know all of this. Well, it's thanks to modern technology. Astronomers can now study stars and planets in other solar systems to learn about how our own solar system formed. They can also use telescopes to look back in time and see how stars exploded in the past. By studying these exploded stars, astronomers can learn about the elements that they produced and how they spread them throughout the universe. It turns out that the elements that are essential for life are rare in the universe. That's why we're so lucky to be in a solar system that has them. Most stars don't produce the right mix of elements because they're not massive enough. Stars that are less massive than our Sun do not live long enough to fuse helium into carbon and oxygen. Sure. And stars that are much more massive than our Sun produce so much iron that it is toxic for life. So we really are the lucky ones. We live in a solar system that has the perfect mix of elements for life as we know it. We have the technology to study stars and planets in other solar systems to learn about how we got here. Who knows what other discoveries we'll make in the future? Maybe we'll find out that not as unique as we thought, and that life really does exist elsewhere in the universe. Thanks for watching.